Factoring polynomials by grouping. We'll start by recalling how to multiply binomials. We could use the double distributive and take the x and multiply it by 2x and -7. Then take the positive 3 and multiply it by 2x and -7. And we'll notice that the two middle terms can be combined. And this would be the product of the two binomials. But to factor by grouping, we'll typically start with a polynomial having 4 terms. So we will forget about this trinomial and instead factor this polynomial. And to factor by grouping, we just group the terms 2 at a time. Sometimes we use the exact order that the terms are in, like in this case. We can factor out a common factor from both groups. So we'll take out an x from the first group and a 3 from the second group. Now notice you have a 2x minus 7 factor that is common. We will take that out and rewrite our polynomial as 2x minus 7 times x plus 3. And that makes sense because it matches what we had at the top of the page. So we'll use this process to factor another polynomial. This has 4 terms. There is no common factor that I can take out of all 4 terms, so let's group them 2 at a time. We'll factor out a 2x from the first group and a 7 from the second group. The x plus 2y matches. I can factor it out, leaving me with x plus 2y times 2x plus 7. That is the factored form of the polynomial, and the strategy I used was factoring by grouping. We'll use this strategy again for another example. So we like to group terms that have a common factor. So sometimes that involves rewriting the original expression. I'm going to rewrite it with the 3's first and then the -8's second. So I'm going to group this into 2 binomials. It will be, the first group will be 3y squared plus 3. But then I'm going to subtract off 8y cubed plus 8y. Notice how I had to think about my signs. Let's factor out the GCF from each binomial. We'll take out the 3 and the 8y. The y squared plus 1's are going to match, which we can factor out. Our final answer in factored form is y squared plus 1 times 3 minus 8y. All right, another example. This one's a little different because there is a common factor that all 4 terms share. We can factor out a 5 and an a squared from all of the terms. And now that polynomial in parentheses is what we're going to factor using grouping. We'll bring down the GCF, but focus on the polynomial in the parentheses. We'll group that into 2 binomials. We'll use the exact order that's shown. The GCF I'll take out of the first group is 3a. And we'll notice the 3b minus 1 matches. We'll factor that out and rewrite everything, remembering to include the 5a squared in my final answer. So that is the factored form. One last example. At first it looks like there's a common factor I can take out, but no, there is no 3 that's common to all terms, there's no a that's common to all terms, there's no b, so there is no common factor. We will group this trinomial into 2 binomials. We'll use the exact order that it's in. Let's factor out a 3a from the first group and a 5 from the second group. And now you'll notice the binomial in parentheses almost matches. If it were just in the reverse order, if that second group were just AB minus 6, then it would match perfectly. So we're going to take the opposite of the second binomial and kind of force it to match. Notice we just multiply by -1. That's how we reverse the order of that binomial. Let's simplify this to 3a times ab minus 6 minus 5 times ab minus 6. Now we'll notice that that ab minus 6 matches. We'll factor it out. Our final factored form is ab minus 6 times 3a minus 5.